Hey mathematicians, let's do our homework. All right, so we have algebra, my favorite kind of math, and we have algebraic equations that we are going to solve. No pictures, no drawings, you don't have to write the equation. I gave them to you. You just need to isolate your variable. So, for example, when you see a coefficient and a variable smushed together, that means that you are looking at 2 times m equals 48. So to isolate m to get it alone, you need to do the opposite of 2 times. You're going to divide by 2. So we show this is not me underlining it, this is my fraction bar, my division symbol. And if I do it to one side of my equal sign, I have to do it to the other. This now becomes a fancy 1m and a coefficient of 1 we don't need to write. We have successfully isolated our variable. You need to divide 48 divided by 2, and that gives you your solution. Now let's jump to number 3. Because we've done plenty where the variable, like in number 2, is on the left-hand side, which is where we're kind of used to seeing like the problem. But that's not always the case. In number 3, the variable, that letter v, is on the right-hand side of the equation. There's nothing wrong with that, but that just means that I am now looking at v. I care about this negative 13. I am not trying to undo the 12. That has nothing to do with v. I'm trying to undo that minus 13, so I'll do the opposite. I'll add 13 to both sides. This gives us 25 as the same as v, which is isolated now on its own. That's our solution. So you need to do that for each of these. Let me scroll through and see if I see any fun ones with fractions. No real, well, I guess this is a real fraction, but no fraction that are visibly multiplying. This is a fraction with a coefficient secretly of 1/4, because that's really 1j. So we can rewrite this like 1/4 times j equals negative 3, and you can multiply by the reciprocal of 1/4, which means the flipped version. This makes a fancy one, this makes a fancy one. Multiplying two reciprocal fractions leaves you with just 1, in this case, just 1j. This is multiplying by the reciprocal of 1/4, 4/1, which is really the exact same thing as 4. Because remember, a denominator of 1 is hiding under every whole number. We just don't need to really show it. If you wanted to make them both fractions, you could. We'd simplify at the end. Negative 3 times 4 is negative 12. 1 times 1 is 1. And again, like I said, you do not need to show me a denominator of 1. This is a solution of negative 12 because negative 12, divided by 1 is still negative 12. All right, let's flip over to the back side. On the back, we are practicing some graphing, a skill we're going to need in our next unit when we graph equations, when we plot them on a coordinate plane. I love doing that. So let's refresh our brains. Ordered pairs go x, y. So the x-axis, which is this one that goes horizontally, comes first. So when I'm looking for the ordered pair 3, -1, I am starting by looking side to side for a positive 3. I find that right here. There's only one point that falls on this positive 3 from the x-axis line. I'm thinking our answer is point Q. But you got to go check the y-axis for the -1. Does this point for Q match up with -1 on the y-axis? Yes, it does. In which quadrant will you find this point? Right here. You can actually graph it in the picture above if you want to. Or you can think about, is the 5 positive? Is it negative? What do you know about the signs of quadrant 1? What do you know about the signs of quadrant 3? My favorite quadrant. What do you know about the signs of quadrant 4? What do you know about the signs of quadrant 2? Because actually you don't need to plot this anywhere. You can just say, oh, I know that the x values are positive, so that puts me in these two options. And if the y values are negative, then you can figure out where it goes. Which of the following points will be on the x-axis? The x-axis is this one right here. So think about, that could be any x number in the whole wide world, but it could only be one possibility for the y coordinate. So think that through, and then we're done with our homework.